So, so I think firstly, to talk about the circuits and the sequences, we need to better understand which are the pneumatic components that make it. So I think the best way to start is talking about the actuators, which are the pistons that I'm drawing on the screen, and also the four/slash two-way valves. I think it is said like this in English, but okay. So what we need to know is that when you have an actuator, a two-way actuator as the ones we normally use, you have two ways for the air to enter, and if it enters on the right, it moves the piston as it is here, because the air enters here and it fills the space with air, and then the piston goes out and reaches this sensor, for example. I'm gonna explain sensors later. But as it is here, what is happening is that the air is entering here, so it's filling these spaces and it makes the piston stay closed. But how does it do it? It's used the valve. So on this first position, I left both of them like together so we can better see it. But here, the compressed air is coming out of this way, and this way is entering here into the atmosphere, so it doesn't receive air, the compressed one with pressure and all. And as it is coming out of here, if it is connected to this piston, the air will come here and it will fill it and keep it closed. But when you commute the valve, so to stay it using this side of it, you gotta receive pressure here, and then it stays like using this side of the shift. It's basically if you receive pressure here, you use this side, and if you receive pressure here, you use this side. So this is important to decide how the valve is when you're starting the drawing, like the starting position of your drawing. It is really important to know what's the position of the working valve. This is the principal valve of the main valve of your circuit, because it activates the actuators. So basically, it starts like this for the two ways, because just explaining, because it has 4 points of entering and outing air, outlets and inlets of air. There are four, and there are two because two positions that you can have, the left one or the right one. And basically what is happening, I'm gonna write it in red so it's more visual, is that it's connected like this. And when you apply pressure here, you commute it, and no, sorry, when you this is when you apply pressure here, but when you apply pressure here and you make it commute to the other side, you use this side. And in this side, what is happening is this side will be connected here, and this one will be connected here, because the connections are the same, but what moves, it's like you have two connections here, and here it is like movable, so you can do it like this or like this. And our starting point with the actuator closed is like this, so that's what we have here. But when we apply pressure to the left side, we do it like this, and then it shifts to the position we have here. And in this position, what is happening is the working pressure is going directly through here, and then it fills this size of the actuator, which was really small, but since it begins to apply a pressure flow, it just opens the piston and it gets like this in this position. And to make it go to the other way, what you have to do is move to this one. So you apply pressure here, and then this thing moves, and you will get the first position that we had here. So when we have this again, you're applying pressure here, and this pressure is making it close. So one thing that is really important is to make sure that you write your actuators and your valves and the way that the pressure goes. It needs to make sense, because sometimes the pistons can be drawn like to the other side. So instead of having it like this, you could have it like this. But then you need to change the way that the valve activates the piston to go out, because that way, if you apply pressure on the left, it would activate the piston and not deactivate it as it is on this example. So you would need to change the the direction of the arrows. So the activation is applying pressure here, like this. For the activation, it would need to be like this, and for the deactivation, it would need to be like this. So you need to make sure that this is drawn correctly, because this is probably will take a lot of points out of you in the exam. And also we need to make sure that this is drawn, because it receives pressure in this way, and as it receives pressure, it commutes or not. And also you cannot forget to draw the atmosphere, which is this triangle, and also the pressure. And it is also really important to remember that in the circuits we tend to have like the pressure line below, which is like the pressure for all the components, for all the valves and everything, for the sensors to shift. But you need to draw the working pressure, especially on the valve, because the pressure that is going directly on the actuators, it needs to be high, so it cannot have gone like through all the components of the circuit. So you need to make sure that this is not just like the pressure line that you have on the whole circuit. Okay, so continuing, we have 32 ways elements, and the main ones are the buttons and the sensors, which we use a lot. But basically on the button, what we have is two positions. We have a position where the air is not flowing from the pressure to the line where we connected, and the position where it commutes. So basically the okay, so it's not moving. Okay, just ignore it. And this position, the air is allowed to flow. So this button, it releases this air to go. And when it's on the other position, it just doesn't flow air through there. So it's as if the circuit was stopped or closed. And this button is a little different, because this one you just press, and then the string comes it go back to the initial way where the air is not flowing through here. But this one, it has a, we can see that it has a little thing here, and this is called a retention button. So when you press it, it will uh, it will shift to the other side, and it won't come back until it's pressed again, like, or for a determined period of time. Usually it is not like just a button, like we can use like a valve that, I don't know how to draw it, but for example, you have a valve here and you just like change it for off and you change it for the on. So, like a little kind of a potentiometer. So we just turn the valve and it's on or off, not exactly a button that stays on. But what happens is once it's pressed, it allows the pressure to come this way, and then the compressed air keeps flowing. And this type of button is used usually on continuous cycles because you want to make sure that the cycle continues after it finishes, so you don't want to have to go and press it again once the last element is reached. So you basically use this to make your work more lazy, so you don't have to press anything again. And it's basically like this. And the sensor is one of the main parts because this thing, it is connected to one of the positions of the actuator. So basically here, um, in practice, what happens is that you have the sensor here and the air is coming directly to the valve that activates or not, like a little tube, kind of a wire that connects the compressed air here. But on the circuits, we're not gonna draw it like this because it would be a lot of lines and a lot of messy things. So we just kind of use the name. So SA plus, we would write here SA plus. And what this means is that when the piston reaches SA plus, it activates this sensor. And when it activates the sensor, what happens is it would basically, just sorry, it would press it. So we represent it by this little wall next to it. And then, since it's pressing, it commutes. And just it commutes as the other valves do, so it's basically the same principle. But when it commutes, it allows the pressure to go from this side to this one, and it activates a certain line of pressure. And it's basically this. And since it's ruled by a string, when this sensor is deactivated, which means, for example, when this actuator is not anymore on SA plus, when it starts returning towards SA minus, it stops pressing the sensor, and then it can commute back to this position. I'm not good with this kind of drawings. Okay, but I think, I don't know what happened here, but I think it's okay. I'm just gonna ignore it and just draw it like this. Yeah, okay. And that's it. That's what a sensor does. And I think that it's important here is, since I don't have a pressure line, I just wrote like all of the compressed air coming on each one of these elements. But if we did have a pressure line, like a line here with the connected pressure, and we could have just done that, because since these are not like the main valves that are activating directly the actuator, since this one could have not been connected to the pressure line below, but this one could, because it just needs to activate. It doesn't need the working pressure, which is the pressure as it highest, so it doesn't need the, like, this one can have like some loss of pressure by activating the different components and all, but the one above, it cannot. Basically that. This valve, it's the one that's mainly used on the cascade method. I don't know if waterfall method. I think it's waterfall. Makes more sense in English. But okay. So basically it is a memory valve. So on this valve, what happens is that we have more positions for where the air can come out, because here we have 5 positions to connect or receive pressure. And on one of the positions, which is where it's receiving pressure here, what happens is that your pressure goes through the middle line and it comes out of the right way. So basically it would activate this line, which can be applied in some place you need it to be. And this pressure is being ignored. And what happens when you commute here, you apply pressure here, and then it just shifts this way. A second. When it shifts like this, what happens is your pressure will come directly on the left side and your right side will be not used. It will just come to the atmosphere. So basically what you have is that the positions that the air that's being discarded is not the same, because that's what we had on the for the two ways, and this one it is not the same, and this makes it able to hold the memory. Now we have things that change the way the air is flowing. So here it's a valve that controls the flow in one direction, because basically if the flow is coming this way, it will get here, and this thing makes the air flow really slow because it strangulates it. So what is happening is you have kind of a thing like this, and the air is flowing here, and when it reaches this point, which is represented here, it's forced to go slowly. So you control the speed of the air flow, and it is just in one direction, because if you go through here, this thing doesn't block the air to go from right to left. It just blocks it on left to right. Because if you're coming from the ball and you reach the kind of arrow thing, you cannot go. Your air cannot be moved. But if you're coming from the arrow and you reach the ball, you can just like push the ball, so you can move the air. And that's what happens. So if you're going through here, it's easier and the air can pass in a normal speed. But if you're going from left to right, you cannot go through the bottom way, and you're forced to go slowly. So this is used to slow down the speed of the air in a certain part of the circuit. And using the same logic, we can build a temporizer. I don't think it's kind of a clock. I don't know the name exactly in English, because temporizer doesn't sound good. But what you have is you're receiving your air and it's forced to go slow, right? And then this air, which is slow, it is used to fill a reservoir. This reservoir is filling at a slow velocity because the air is forced to go slowly. And then once this reservoir is full, the air comes through here. Because before it just stops to fill the reservoir. But once it's filled, it commutes this valve. And once it is commuted, it allows pressure to go through here. So basically what it does is it just forces the air to stop a little, and you can control the speed of the air through here, and also the size of the reservoir to apply a certain time that you want the circuit to wait. But usually we just write like this. We don't need to determine the specific time when we're doing the exercises. But what happens is, for example, if we have a sequence with t, a minus, b minus, for example, this is the t. Before you do the a minus, b minus, you apply the clock. So it is represented by the t, and every time there's a t, you gotta draw this clock. And that's it. It's a little hard to remember, but once you get what is happening here, so for example, that you have to slow down the speed of the air, fill the reservoir, and then you commute the valve, it's easy because you just got to remember that, and you don't need to just memorize something. Okay, so these two valves, they are really important, especially in the step-by-step and the waterfall method, and they're pretty logic also. Basically, what you have here is you have one inlet of air, another one, and an outlet. And what you're saying here, this is an OR valve. Let me write it so it's more visual. This is an OR valve, and this is an AND valve. On the OR valve, if either one of the inlets is receiving air, the air is passing. So basically what is happening is, if you have air coming out from here and you don't have air from there, it will work as this little thing which doesn't allow the air to go out. So it's just, it reaches there and then it can go out. So your line is with pressure if this side is on. And also, like, if you, it will be weird because of the, but like if you move it, I don't know if I'm able to do it like this fast. I'm sorry for my drawing problems. Okay. But if it is like this, the same thing will happen. So if you receive pressure from here, it also can activate the outlet. And that's basically it. So it's or, because if you have pressure here or here, you have pressure on the outlet. Yeah. And the end, it's basically an end. So you only have pressure on the outlet if you have pressure on both sides. This is good for when you have like a synchronous movement. So basically you have, for example, A plus and B minus, and then you have to do C plus. And to activate C plus, you need both of this to be at this place. So you're gonna have to have two sensors, one for SA plus and one for B minus, and this sensor will be connected by an end, which is weird like this, but, and then like the signal of both of them connected by an end will activate your movement of C plus. So it's basically that. And also a lot of things in the step-by-step use and, but I'm gonna explain it later. So it's basically this. I hope at least the elements are well explained. I know I made some mistakes in the middle, like maybe some explanations were a little confused, but I hope it helps at least a little.